for you. Alright, appreciate
Hey,
it.
so here's a demonstration of the robot in full action. Give you a shot of the robot resetting.
As you can see, it starts off right here as a reset, and so it's going to target to cup 10 because of 10 cups. Made the first shot. Has to be manually reloaded. It realizes there's only 9 cups left, so it's going to shoot for cup 9, which is the back right cup. Made it. The cups also have to be manually removed. Robot goes to reset mode. Looks for cup 8. Makes cup 8. Shoots a cup 7. Goes a little bit wide. There's a couple of reasons for the inconsistencies as explained in the report. Human error by not loading it would be one. The biggest problems is one, when the ball gets wet, sometimes the density changes of the ball a little bit. We put it in the when it goes in the water, it gets a little bit heavier, so it kind of falls short a little bit.
Oh, bounced off the wall and made it.
We have only 6 cups. Goes back to reset mode. Shoots for cup 6, back right. Makes it. Some of the reasons for the inconsistencies is that the strength of the servo arms, we had to maximize the strength of all of the servo motors, and because of that, it puts a lot of torque on it, and so it's not always consistent. Makes cup 5. Another reason is that we had to go with a plastic knife and a plastic spoon on the end of it, connected with electrical tape right here. The reason we did that is 2 reasons. One is because it gives it a nice long arc to it. It also allows it to make cup 4. It also allows the ball to actually roll off of the spoon edge right here. So it gives it a little bit more of a throwing motion like that. And also, if you kind of see, when the robot arm throws, it gives it a little bit of a twang. So it flexes a little bit, and gives us a little bit more of a range. One of the hardest parts about making this project was to get the end effector, make it be able to throw long enough. Because the range, we were only making at least half the range. So this is the only way to make our range that we needed. And unfortunately, we needed to sacrifice some of the accuracy of it. As you see, there's 3 cups left. Between every throw, when it realizes it doesn't make it, it needs human input onto the computer. TJ over there puts in and asks for if it went very short, about made it, long, or really long. And based on those 5 inputs, it will add an offset to the final throw. And that final output is changing the distance on this last servo arm right here, like 4. And so, if it knows it has to go longer, it will let go farther. If it has to go shorter, it will have to go shorter. Makes it? So basically, the only difference between all the throws is it has the same throwing motion in all of them, but this arm right here, link 1, changes based on what direction it needs to throw, and the last link right here changes based on how far it needs to throw. Makes cup 2, and I got 1 cup left. Makes the last cup. And the last goal we made, goal 6, is that it needs to realize that it won and needs to celebrate. And that's our version of raising the roof, robot mode. As you can see, it missed 6 cups. Overall, it's pretty good, considering the difficulties with the servo arm, and difficulties with the program, and the difficulties with the end effector. And we consider that pretty good success.